For this example, we're going to determine whether the two circles C1 and C2 intersect. Then we find the point of intersection if these two circles intersect. So to find the circle intersect or not, we are going to solve this equation simultaneously. So circle number 1, x squared plus y squared minus 4x plus 6y minus 12 equals to 0 will be our equation 1. Then second circle will be our equation 2. So we try to solve these two simultaneous, where equation 1 minus equation 2, we can see our x squared and y squared can be cancelled out, leaving unknown x, and here plus 3y, then minus 8 equals to 0. So normally when we having two circles intersect, so our first procedure here when we solving these two simultaneously, actually we are finding this common line. So you can see line equation is forming. If we circle intersect at one point, also we are finding this common line. Alright, so in order to find the point, so we are going to substitute this common line back to the either one equation. So for this line, we express x as a subject. For us easier to substitute, we're going to sub equation 3 into either one equations here, so either one circle here, so we can meet the intersection point. So we choose substitute it into equation 2. So 8 minus 3y squared plus y squared minus 5, we substitute 8 minus 3y plus 3y minus 4. We try to solve this quadratic. So expand this, it gives us 64, then 2ab minus 48y, then b squared, it gives us 9y squared. And when we rearrange the y square, we have 10y squared. And then we have minus 48 plus 15 plus 3y. So it gives us negative 30y. Then the constant here 64 minus 40 minus 4. So it gives us 20. Therefore, we can get a quadratic equation here. We simplify by divide by 10. So to determine the circle intersect or not, then it will be depends on this quadratic can be solved or not. If we can find two real roots, means the circle intersect at 2 points. If this quadratic, when we solve the roots, we finding we get one roots or equal roots, so means our circle will be intersect at 1 point. Sometimes when we solving the quadratic, it won't have roots, means the circle will not be intersect. So to determine the circle intersect or not, it will be depends how the solution on this quadratic. Therefore, we are going to use discriminant of the quadratic, which is b squared minus 4ac, to identify out the type of the roots having in this quadratic, so that we can answer the first question, determine whether these two circles intersect or not. So when we take out the b, negative 3 squared minus 4a is 1, c is 2. We can notice that we have 1. So this is b squared minus 4ac greater than 0. Indirectly, we can prove that this quadratic having two roots, so the circle intersect at 2 points. It will having two real roots, therefore the circles going to intersect at 2 points. Then we proceed to solve that quadratic in order to find out what is the point of it. So continue from the quadratic y squared minus 3y plus 2 equals to 0. So we know that we are having two real roots. In solving, we're getting coordinate 1, y equals to 1 and y equals to 2. Then we're going to substitute into equation 3 to find out the x. So therefore, we're having x equals to 5 and y equals to 1. And another coordinate is 2 equals y, x equals to 2, y equals to 2. So this is they are the point of intersections. So bear in mind to put your x value and y value in bracket to identify this is the right thing for coordinates of the point.